Hi, my name's Joe Bostian, and I'm a mainframe open source architect at IBM. I'd like to talk today about the interest shared between the open source and mainframe communities. While each community operates in different ways to achieve a certain set of goals, the goals themselves are often common. In reality, there are lots of ways that the open source and mainframe communities can use open source architecture to leverage the unique strengths of the mainframe to make the overall enterprise compute environment more efficient, secure, and resilient. One of the truths mainframers like to recite a lot is that the mainframe is a system of record for much of the world's transactional data. Although it's hard for a consumer to find direct access to a mainframe, the ATMs, credit card readers, and online web interfaces we all interact with usually talk to a mainframe when it's necessary to record an official exchange of funds, goods, or services. A philosophical difference between the mainframe community and really the rest of the IT industry is the largely forgotten concept of vertical scale. What this means is that qualities of service like security, scalability, and availability have been prioritized at the lowest levels of the mainframe hardware and software stack, whereas IT infrastructure based on commodity hardware usually compensates with horizontal scale and redundancy managed through software. Does the mainframe fit into widely accepted modern architectures like cloud? Of course it does. But when we integrate the mainframe into an enterprise, we should take advantage of all its special capabilities to maximize efficiency and return on investment. An example where inefficiencies are often introduced into an enterprise architecture is in the creation of a physical data lake. This is the first-generation cloud-based idea that data across an enterprise should first be collected into a central repository and then processed by application developers or data scientists to gain greater insights. It's an architecture ready for retirement in favor of a distributed view of the enterprise, where compute nodes of varying capabilities are utilized to their maximum extent. Why would you build an extensive redundant infrastructure simply to copy data from an extremely capable mainframe, the same way you would a dumb social media stream or an IoT device? Bring some of your application workload to the mainframe, act upon the local data there to create intermediate results, and integrate a much smaller payload into your data lake. You'll save lots of infrastructure costs, reduce latency, and improve the performance of your enterprise. And you won't have to fundamentally change your app dev pipeline to accomplish this. Old crusty mainframers from way back often point out there's nothing new in the open source world. They're just different ways of doing the same thing. So what? One could easily argue that anything newer than a Turing machine is just a different way of doing things, yet the benefit of doing them in a modern way is self-evident. Although the IBM 360 mainframe established the world's original business computing architecture, today's enterprise has evolved interfaces that are far superior. Where we often jump the tracks in the debate about the mainframe's significance today is when one side assumes that today's Z15 does things the same way as the System 360, just with a faster clock speed. Today's mainframe is world-class in every way, but there's always room for improvement. Open source infrastructure is vitally important to the mainframe for several reasons. One of the biggest developments in the open source world over the last 10 years or so has been the emergence of the so-called freemium model, where a project is started, providing a set of base functions to users at no cost. The founders of the project often go on to create a commercial offering that builds upon the open source project with commercial features for a fee. As users begin to adopt the base functions, the commercial offering builds a ready audience of potential paying customers. Even users who don't upgrade are valuable to the founders because a talent pool grows around the project, further supporting a commercial offering. Every time a student enrolls in a course today, they're not just building their own skill set and achieving technical eminence. They're making use of a technology stack that builds mindshare for the projects of that stack. The mainframe's effectively cut off from an important user base every time it's omitted from one of these technology stacks. The modern enterprise is a heterogeneous assembly of resources and compute nodes from different vendors. In order for these vendors to interoperate well, they often establish standards organizations to set the rules of engagement and give their customers confidence in the longevity and relevance of their environment. These standards bodies can be official organizations like the Internet Engineering Task Force or the Linux Foundation, or they can be de facto standards that a large number of users informally accept, like PDF. Sometimes government sets legal requirements for standards compliance as part of the vendor bidding process, and sometimes clients simply require standards conformance as part of a private contract. The dynamic nature of the open source community is driven by the unbounded number of projects and people involved. Anyone can create a project and build a community around it. It's practically impossible for any single vendor or organization to dictate industry direction because anyone can challenge the status quo with their own ideas and projects. New and usually better solutions emerge all the time for existing problems and tasks. There's no part of the IT universe that can't be addressed by an open source community. An open source presence has been building on z/OS for several years, and IBM has played a prominent role in the open source world through several projects and organizations. A collection of open source languages currently runs on z/OS, starting with Java, which has been around since the early 2000s. Python's been available as well for a number of years through different offerings, and more recently languages like Node.js and Go have become available. Open source projects like Zoe and WebSphere based on Open Liberty have aligned application development on z/OS with modern frameworks and pipelines from other platforms. IBM Z continues this alignment, and components like Ansible are similarly making the operation and automation of processes look and feel like those across the enterprise. Rocket Software provides a suite of open source tools for the Unix System Services environment of z/OS that makes it look and feel more like a Linux platform. Open source plays a key role in the new z/OS container extensions feature, also known as ZCX. ZCX actually runs a Linux kernel in a z/OS address space to support Open Container Initiative compliant containers. Containers built for the IBM Z platform can be downloaded from well-known registries like Docker Hub or the Red Hat Image Catalog. Open source has been incorporated in commercial products for some time. Offerings like Watson Machine Learning for z/OS and IBM Open Data Analytics are mostly collections of open source packages with configurations and toolings to optimize their use on the mainframe. With the implementation of ZCX, IBM has enabled a shared ecosystem between the Linux and z/OS platforms for the first time. What this means to z/OS is that users have immediate access to a library of containers that the Linux community has developed on Z for many years. These can be pulled and deployed in a ZCX appliance without change, using common open source interfaces. The operation and use of these containers within a ZCX appliance is identical to other Linux platforms. The Linux on Z community benefits from this as well because it drives development of modern applications to access the subsystems and data that originates on z/OS. One of the first examples that we've published to illustrate ZCX use demonstrates a configuration of open source and z/OS Connect to interact with Kix. Many of the key components of this application were developed on Linux on Z and containerized. This allowed the application developer to assemble these components to interact with z/OS interfaces and create a complete workflow. The developer of this example application comes from the z/OS community, and he started his effort in order to learn the ZCX environment. He told me he expected it to take a couple of days, but he was able to get it running in an afternoon. This rapid application development was only possible because ZCX enables true cross-platform development and deployment. Any container image developed on Linux on Z now runs on z/OS, and conversely, any container image developed on z/OS can deploy just as easily on Linux on Z. It means we can now develop for either platform and deploy on the platform that makes the most sense for a given environment. Decoupling the development and deployment choices like this allows us to break down the barriers between z/OS and Linux on Z to create an IBM Z ecosystem in place of two different operating-specific ecosystems. This becomes more important as we build out container orchestration capabilities and associated infrastructure like IBM Cloud Paks. It's also important to know that although ZCX provides a very important capability for IBM Z, It doesn't mean there's no longer a need to port open source natively to the Unix System Services environment of ZOS. Although USS lacks some of the app dev infrastructure present on other platforms, it provides the necessary interfaces to interact directly with ZOS resources. There are many workloads that require this kind of access, particularly in the DevOps domain. The key takeaway here is that tighter open source integration for IBM Z will include containerized and native software implementations across both Linux and ZOS, and clients will have more flexibility to develop and deploy as they see fit. It's hard to overstate the importance that organizational culture and roles play in the success of open source efforts on IBM Z. The need to have a highly secure system of record means that most ZOS environments have severely restricted access that many open source developers and architects will see as impossible to overcome. These environments can be configured to create a useful open source workspace that developers will find familiar, but it requires cooperation between people with roles who don't usually interact regularly. Open source development usually requires open access to the internet so that content can be pulled from several different locations and assembled into a workload. This open access is a non-starter for ZOS production environments. Most open source repositories and registries support a local offline configuration, and important package management components of the development toolchains can point to these local repositories. Some of this infrastructure can be hosted on Linux on Z, or even an x86 platform, as long as it's inside the corporate firewall and the contents are curated to satisfy security requirements. The application developer, solution architect, and ZOS systems programmer have to cooperate to create an internal sandbox or staging area for code development and testing, with limited access to the outside world. This space can contain the same infrastructure used for development on other platforms. Once a workload's completed appropriate testing and verification, the workload can be deployed to production. In this environment, the developer may not have all the authority to deploy workloads that they enjoy on other platforms. The ZOS system programmer will need to help the architect and developer build out and maintain the sandbox. None of this, though, requires any of the parties involved to retrain significantly to support the effort. Everyone applies their unique skills to make the team successful. Teamwork within a development and deployment team and with key open source communities is essential. Everyone involved has their areas of expertise and preferences for how things are done, but they all need to agree on the best architecture and configuration for an optimal open source environment. This means that everyone needs to be comfortable with implementations that may not align with the way they've always done things. Open source brings a social dimension to the ZOS environment that didn't previously exist in many cases. Similarly, there are key priorities in the ZOS world that are generally understood in the open source community, but probably haven't been fully appreciated in the same way. Ideally, the team produces a solution that builds on the strengths of each community. I'd like to highlight a few online resources meant to assist anyone who's working to create an open source environment on the mainframe. Of course, we all know the Open Mainframe project. It's why we're here today. You've probably also heard of Zoe, the OMP's most successful project to date. There's another project that the OMP hosts called Ambitus, which is Latin for compass. The purpose of this project isn't to provide a specific piece of enabling infrastructure, but to help people find and share knowledge about open source and IBM Z. More specifically, there are two areas of primary focus for this project. The first is to provide examples and how-to information. This includes comparisons to other platforms that show how IBM is similar and different. We want users to avoid known pitfalls and make use of best practices with open source environments. This includes information for both containerized and natively ported workloads. The second focus is to serve as an incubator for developers who are in the process of upstreaming IBM Z changes to existing projects. There aren't enough open source communities today that support IBM Z as a platform. By providing a public forum for developers to stage their changes, we can all see the work in progress to expand the mainframe presence in this space rather than waiting for an upstream community to accept a pull request. The content here is meant to speak to developers new to the mainframe platform, as well as seasoned mainframe systems programmers who need to understand something about the open source environment. Our goal is to make Embatus a portal for information and a public square for a viable open source community, in the same way that the Open Mainframe project does more generally. Another useful resource is the IBM Z and LinuxOne community, which has a wealth of information, some of which predates the Open Mainframe project. The developers associated with this community are true experts in the field who have a lot to share. One of the most useful resources that I regularly reference is the open source software table for Linux on Z and LinuxOne. This table shows all the packages that the Linux on Z ecosystem team has validated across different distributions and container packages. It's a really good place to start looking, whether you need something that runs natively on Linux or in a container that deploys on Linux or ZCX. Here are the links to the resources above, as well as the IBM ZCX content solution page. We encourage anyone interested to not only use these resources for reference purposes, but to participate actively in these communities and share your experiences. We're always looking for like-minded people who want to work together. None of us knows as much as all of us, and the more we work together as a community, the better the mainframe platform and open source environments support one another. Thanks a lot.